Warning message. Reset filter timer.
Remind me after class. All right, so anywho, thank you. Anywho, so here's the deal. You may recall we did some equations like this earlier this year where x equals 20t and y equals negative 4.9 t squared plus 60t plus 2 or some such. Oh my gosh, it's like arc. It's projectile flight. You're right. How far does it fly this direction, Mr. Room? Well, I could find that we've done that, and I don't care about that. Today, I want to know how far does it go along the path. In other words, what is that arc length? It's great. Here's a question for you. At t equals some time, from there to this other point up here, you went some change in x, yes? Right? In some amount of time, yes? And you also did some little change in y action like this, didn't you? And over a short period, it's basically can be thought of as a straight line. Right?
There's a theorem for that.
It is. Good old Uncle Pythagoras' theorem, yes? And so as you know, the length would be dx dt squared plus dy dt squared screwidicated, yes? And then I feel like you'd sum them up, yes? Yes? And you do a whole bunch of these little farts, like so, right? You get the picture all the way across. Now, Zach, if I only did 10 of them, that would not be a very good approximation, Zach, right? But what if I took the limit? What if I take the limit as n goes to infinity of this sum? What would I get? Oh my God, I get the integral from a to b of the square root of dx dt squared plus dy dt squared dt. Right? Notice that t is our variable this time. Yes? So we'd like to know how far does it travel along its path from there to there. So, first things first. Probably ought to figure out how long this sucker is in the air for. I'm going to do this problem. Shh. Thank you. So let's take our calculators, or Desmos, and let's graph this thing, shall we? Graph that. Find out when its 0 is, if you would, please. Go ahead. Let's ask the great Desmos. It doesn't rhyme. The great googly moogly rhymes. Desmos.com. There it is. Got you. I got you. Plus 1? Oh. Mr. Green, why didn't you use an axe? I don't know, because I'm stupid. Oh, there it is. Shh. Huh? Oh, well, that blows. What's it supposed to be? 4.9. There we go. Cool. It's about 12.278 seconds, yes? That's all right. Now, of course, how fast is it traveling? It's traveling at 20. So 20 times 12 point whatever. What is that? Do the math. Somebody do the math. What is that? That thing right there. 12 point whatever I said times 20 is what?
245.5.
Boom. That's how far it travels downrange. Yes, that's great. But I want to know how far does it go. Listen, I'm not a math person really or anything, but I feel like this straight line distance down here on the x-axis is a lot shorter, you see, than it is to go up and back down. Yes? Right. So, how are we going to do this thing? Well, we're going to integrate from 0 to, what did you say, 12 point something? Now, what is dx dt on this problem? Well, I feel like it's 20. Right? Right? Look at it. See it? dx dt is 20. And this one here, dy dt, is what? Negative 9.8t plus 60. Okay? Now, good news, bad news. Can I do this? Can I do this integral by hand? No, you really can't. Almost none of them can you do by hand. They're gross. So what am I going to do? Well, I'm going to use my TI-89, or I'm going to use Wolfram, or whatever. Now, bear in mind, on the test, there will be a portion where you're allowed to use Wolfram or your TI-89, and there will be a part where if I see you touch it, you are going to lose 1,000,000 points. Literally, 1,000,000 points. Okay, so if you're going to use Wolfram, you can just do integrate. Oops, integrate. And then it's the squirt of, what did I say, 20 squared plus parentheses negative 9.8 t plus 60 squared comma t, no, yep, comma t, comma 0, comma 12.278. Give it to me. I hate you. Well, that's a great question. Why can't I do it by hand? Oh, why didn't it integrate that for me? Why didn't you integrate it for me? This is going to piss me off if they change that, because that's never how it's ever been before. It's ever been. Why aren't you integrating? Integrate the square root of 20. What? What? Where did it go? Oh, I don't care. I'm just going to use it on my calculator. Screw that. I don't even care. They used to be able to do it like that, and now it doesn't want to do it for me. Shut up. Anyway, I'll show you why momentarily. You'll be like, I want to do it that way. You can't. So integrate square root of 20 squared plus negative 9 point. No. Booyah, 463. Yes, as opposed to how far was it when I shot it on the ground? 200 and something. Well, how about that? We shot up in the air quite a ways. So, yeah, following the whole distance is further. Well, who saw that coming? Now, if I were to do this by hand, listen, this is 400. 9.8 times 9.8 is about 100. I'm just going to call it 98. Don't argue with me. It's not that important. T squared. 10 times that's about 600. Times 2 is about 1,200. So minus, I'll say 1190-ish T. It's not really important. Plus 3,600. Okay, now you combine your like terms. You get something like 98T squared plus or minus 1190T plus 4,000 square root dt. All right, go ahead and integrate that, I dare you. You're like, I know, I'll let u equal. Yeah, good luck with that. Good luck with that. But wait. You find some stuff? Hey, that's swell. Thanks. That's all I need. Thanks. Okay, now. Okay, no, you're not wrong. I love this. This is wonderful. Okay, so take this sand here. No, take that bucket over there, sand over there. Here, no, put that stuff on my desk. Put it down. Grab that bucket of sand, dump it into this bucket of sand here, then go wash that bucket out and fill it about half full of water, would you? Thank you.
Where?
Okay, well, I'm just going to tell you that, dear. So, okay, I hear between the lockers. Okay, there's the janitor's closet, you know.
Yeah.
So if you go in there, you know what I'm saying?
Right.
All right. If you go in there, there's a just as you go into the right, there's like a water fountain deal there, and you can fill it up in there. It's like a shower without a surround on it. Does that make sense? Like
Okay,
where the
so
shower
wash
is.
it and fill it halfway.
Yeah, ish. Thanks, dear. All right, now you're like, West Grim, couldn't I complete the square on this business and then, oh my gosh, use trig substitution? Yes, but I'm not an ogre. That would be a horrible thing to make you do. So you're welcome, Lacey. So, Mr. Grimm, how would I do it? Well, okay, there's this way here we just talked about, right? How else could we integrate something that's gross? Oh, Mr. Grimm, could we use midpoint rule? We could. That's right. Or Simpsons, or any of the other rules that we've done on the calculator for approximations. Yeah, exactly right. Okay, so on the test, I'll allow you to use a calculator. I'll allow you to use Excel if you want to use it that way. I don't really care. but we need to do it one way or the other to get the actual answer for this guy. Okay? Now, that said, Lils, I feel like most of the time we don't deal with parametric equations, right? Most of the time we deal with just functions of x. Y is a function of x, correct? Okay. And so most of the time, I would like to integrate this with respect to x, which means I need to get rid of the dt business. Yes? Right? So this is how we're going to do it. We are going to multiply by dx dt outside. You can't just multiply by that, Mr. Groom. Oh, you can if you also multiply by dt dx. Because dt dx and dx dt, when you times them out, what do you get? 1. Right? And Mrs. So-and-so said to us back in the day that you can times anything by 1, doesn't change the value, right? I assume it was Mrs. She might have been a miss. She could have been a dude, too. I don't know. Okay? It could have been. I don't know. Now, does that make sense? Yes? So watch, Hannah. I'm going to take this guy right here, and I'm going to put him inside of the square root. Can you do that? I can. But when I put crap into a square root, what do I have to do to it to put it inside? Square it! God, she's a genius. That's right. So, sister, watch me square it. What? Yes? You follow that? Ah. Okay, so let's start canceling crap. Good. Good. Now inside, I feel like we're going to get what? If you take this times this and this times this, what happens? You're going to get dx. Watch me just do it here, and you just play along and nod your head and go, you're right, Mr. Groom. Hey, thanks. Oops, that's a dx, stupid. Okay, wait for it. Right? Well, can I get rid of this? You sure can. Oh, wait, can I get rid of this? You can, and what are you left with? What's left right there? 1. And then these guys cancel, and you're left with what? dy dt squared, like that. And most books write it in Newton's method, like that instead. Nice. When I was a kid, they just threw this at us, and they're like, "Good, I hope you understand that, go." But where did the square root of the derivative come from, Mr. Thank you. Just sit up here anywhere. It's fine. Appreciate it. You're swell.
What's it for?
Physics. Thank you so much. You're all right. Ooh. Okay. So, okay. I don't know where you're gonna find this. So, I want you to just take ding dong with your head. See if you can find me a more or less spherical rock.
So just a rock.
But if it was more or less spherical, so I can approximate the volume of it.
So
Okay.
like a circle rock.
Kind of. Okay. And then maybe out behind the art building, a brick.
Oh my god.
Okay. By the kiln.
Okay.
Okay. And if he sees you borrow it, I'll bring it. Tell him I'll bring it back. If he doesn't see me borrow it, then I'll bring it back later myself.
So like, what if it's a little circle rock?
That'd be swell. As long as it's more. Listen, more spherical.
More or less circle, yeah.
Not flat circle, round. Okay, go ahead, run on.
Okay,
Now,
got it.
when I was a kid, they always showed us this formula, and they're like, isn't that great? And I was like, well, no, I don't really get where you got it from, yo. It bugs me. Now I get it, but back then I did not get it. So you're saying, Mr. Grimm, if I was given a function, like, for instance, 3x cubed plus 2x minus 1, And I wanted to know from, on the equation from 2 to 7, how far does it take to go along that curve? You're telling me that I'd first have to do f prime of x, which would be 9x squared plus 2. Yes, that's the first thing I would do. And then you're telling me I'd integrate it 1 plus 9x squared plus 2 squared dx from 2 to 7. Literally, that's what I'm saying to you. Now, notice that if I was doing this on my calculator, that's all I need to do because I can just literally plug it in the way it looks. So it goes like this. Integrate square root 1 plus 9x squared plus 2 squared parentheses comma x comma 2 comma 7. Bam, 1015. You're right. That's one way I could do it. Okay. Scream. I love Excel almost as much as you do. Well, I don't think that's true probably, but I'll play along because I really love Excel. She's awesome. Because she's amazing. I don't know. You just know these things. All right. So I'm going from 2 down to 7, yes? Right? Let's use 0.01, shall we? So what would my delta x be if I was going from 2, you see, down to 7, and I was doing it by 100? It'd be 0.05, wouldn't it? Does that make sense? 0.05? Because it's the distance from 2 to 7 is 5 units long, yes? Divide into 100 pieces, that'd be 0.05 in each one? Good. So here, Mr. Goom is going to go equals the original value plus 0.05, right? Divided by 2. That gives me my first midpoint. And then the next one down is that previous value plus the midpoint. Or plus the distance, I should say, rather. Yes? And then I could just drag this baby down to 500-ish. So how you doing? How you doing? Time and a place for a mouse. This pen is great. It sucks for this. Oh, doll, nice throw, dude. It's pretty impressive, yo. What? How far? 200 feet?
No, I wish. 178, so.
Oh, that's pretty tight.
No, sophomore through 208, though.
That's a long way to go.
Yeah. I know.
What? That's too far, Mr. Groom. Yes? How do I know it's too far? What just happened? Oh my God, that's funny. What a moron. Why didn't someone tell me that? Because Garth's a jerk. What a jerk face. I'll just make fun of Mr. Groom. It's funner that way. Ouch. Clear? There we go. All right, now let's try it again. Let's see if Mr. Groom can do it right this time, friends. Okay, if I went one more, it'd be over 7. That's what I was saying, yes? Okay, whatevs. So then what's my function? My function is the squirt of 1 plus, what? Parentheses? What was it?
9x squared.
9 times x squared.
That's not 9 times x. It's just 9.
It is 9 times x?
Oh, never mind. Sorry. 9x.
Freaking me out, man. Plus what? Yes?
Oh yeah, it is squared.
It's squared, right?
Thank you. Okay, boom, boom. Right? Now I take the sum of that from B1 to B100, I believe. Is that correct? Yes, sirree, Bob. Times my delta x, yes? Well, looky there. 1015. Isn't that what Betsy said? Hey, that's pretty good. You know, it'd be really cool. See how close we really are. 'Cause I feel like, yeah. What did Betsy say? Hey, that's pretty close. We're off. We're off by not very much. 0.01-ish. Okay? I'll live with that. Now, that is how it goes when you're doing an arc length function. It literally is that easy. It's not hard. No. Today, somebody was asking me in my class at OIT, say, integration, that's just adding stuff up. I went, yeah. But a whole bunch of little itty bitty farts. Yes? So again, anytime you need to add something, and you're thinking, I could do better by taking smaller intervals and adding them up, you're integrating. That's literally all you're doing. So in this situation here, again, you draw the picture out. Oh my gosh, I was going to add a bunch of these little farts together. But they're not very small, Mr. Green. I could go even smaller. Well, of course you could. But I could go even smaller yet. Well, of course you could. That literally is an integral, by definition. Okay? And so, again, for parametrics, in the parametric format, it looks like this. In the functional format, it looks like this. And they are 100% the same. That's all there is to it. Question? Want to do another one? Lily wants to do another one. You did. I knew you did. Okay, I'll blame it on somebody else. I'll blame it on Angel. All right, Angel wants to do another one. Thanks, Angel. I appreciate that, man. It's great. It's good times. I want to know from 2 to 4. By the way, I almost wrote 1 to 4. Would that be a problem?
Yeah.
That'd be a problem. I need y prime. So it would be what? I feel like this is 3, 1 minus x to the minus 1. So I feel like this is going to be negative 3.
Okay, so this is more like an egg shape kind of.
That actually will work fine. Just bring it up here and sit on the table. That's great. Thanks.
Okay. Did you want an actual brick or just? That is an actual.
I don't know what you mean by an
Well,
actual brick.
This doesn't look like.
It is. It's a fire brick.
That's all I had.
No, that's fine. Did you ask him?
Yeah.
Oh, and he said it was okay.
Yeah, and then I found this outside.
Thanks. Sit down. That's great. That's good call. It's actually no. Don't put it on there. Put it on the ground. So I'll trip on it. Thanks.
It's pretty big.
Okay. No, I'll do. Thank you. Thank you. You're swell. Both of you. I don't think so. Thanks. All right. So 1 minus x to the minus 2 times negative 1, right? 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 Nice. So this is one where you probably back in the day would have done some fancy maneuvering and probably could have factored some stuff out and made this one work. But suffice it to say, here we are. Oh, Groom, you screwed up. Comma x, comma 2, comma 4. Come on, Betsy. Come on. Sometimes you'll run into a few of them that make Betsy really have to stop and think for a few minutes. Nice. That's not very far, Mr. Groom. Well, duh. Hey, look, 1 minus x looks like this. 1 minus x, so it's going to look like something like this dealio. Or 3 minus x, rather. Oh my God, it's almost a straight line. Yeah, it sure is. Yeah, it is. And so, yeah, it's not very big a deal. By the way, this is 2, okay, and this is like 4, okay. And if you plug in the values into the original function, which was 3 over 1 minus x, this would be negative 3, right? And this guy here would be negative 1, I think. Is that right? I feel like that's true. And if you were to draw a straight line between them and find the distance between them, it'd be the change in the y's, which would be 2 squared, right? And then change in the x's, which is also 2 squared. And so that'd be 4 plus 4 is 8. Square root of 8 is 2.8-ish, right? Ish, right? And what did we say it was? Oh, it's a little longer than that. How about that? Because when I do this picture, there's actually a bit of a curve to it, yes? And when I said this little business here, that was treated as if it was a straight line. Notice how it's a lot closer than the first one. The first one, when we said, hey, look, along the ground, how far did you go? Or if you went over the top. Clearly, this is a lot bigger distance here than here, right? But this one is also curvy-wurvy a little bit, hence the 2.95 versus the 2.82-ish. Yes? Jen Bao. Jen Bao. That means no bueno, apparently, in Chinese. Fiona was telling me that today. Because Fiona is fluent, or she used to be in Chinese, blah, blah, and I said, so how do you say no bueno in Chinese? And she goes like, Jen Bao. I went,
With that still should be no good in Chinese. Very,
basically, yes.
very not good.
Thank you.
No, she's
Yes.
Chinese and Spanish, and Spanish.
You're confusing me now. You got going around in circles, yo. I don't know. No. So I can only deal with my Spanglish version of things up here. You're freaking me out, man. I said pause.